going to apologize, but Dave left, because you said real world up there. Don't tell him, okay? I teach statistics, and one of the things I like to do is try to do real world stuff in statistics. Now, let's see, most of the students that I have are not STEM majors. Most of them do not like to prove anything. They're not impressed by that at all. So I tried to come up with a way of getting them to think critically about the world around them. So why not try and teach that? So I use an online learning system that allows them to do discussions that are, asynchronous. When they do these discussions, I don't give them any directions. I just put up the topic, for example, a PSA about a proposed soda tax in New York. The entire directions are discussed. Discussed, that's it. I'm just going to read you actual student comments from here on out, sort of in chronological order of a week-long discussion. I believe that taxing soda does sound right. It's not good for us. We've been trying all sorts of new things with this government, so why not give this a shot as well? Yes to soda tax. Chronological order, remember. Hey, a huge tax was added to cigarettes to get people to stop smoking, but that didn't seem to work, did it? They're starting to think. There's a little bit of thinking going on. They should not say in the commercial, many statistics imply, because then we aren't seeing the information and we believe them because the person seems like he or she knows what they're saying. The actor in the thing was an actor, not a doctor. They figured it out. Hey, are we going to start taxing everything that we think is bad? So all of a sudden they're taking it outside of soda and they're bringing it to other things. They're pulling it out of just soda. Starting to think some more. It looks more like an excuse for the government to increase taxes on whatever they can because it's for a good cause. So now they're wondering, well, what is the cause? What are we going to do with this money? They start to think even more. Oftentimes government crosses the boundaries of freedom. As far as enforcing a special tax on soda to send a message, it's not our duty to dictate what we can consume. So they're starting to think even further outside of the box. Upon reading some of the articles you guys posted, I decided to look up a couple of articles that were interesting to me. They can do Google searches. Yes! All right. I found an interesting article regarding soda tax bill in California. What stuck out most to me in the article was the following quote. They can read. This is the greatest day ever. They're actually reading. I love it. So I went online and did a little research on the statistics of obesity among kids. Obesity has apparently been decreasing. Hey, maybe that study they quoted isn't the whole story. Oh, that's midweek somewhere. This law is assuming that soda is the cause of obesity, and it's putting an easy solution to the problem. Unfortunately, everyone would suffer, blah, blah, blah. They're asking what the cause of it is. How strong is the relationship between drinking soda and gaining weight? And how good are the models that predict a soda tax would reduce obesity 2 months before regression analysis? 2 months. According to the University of Colorado study, the introduction of high fructose corn syrup 20 years ago coincided with the start of the decade rise in the blah, blah. So now they're looking for other things that may cause obesity. Comprehensive implementation implies analyzing all aspects of the issue. In the following study, whose names I won't bother to read, quote, I didn't read that study. Wow. I believe slowly the government is breaching that fine line by indirectly dictating the amount of sugar consumed. They are one step closer to stripping us of our freedoms. But because these politicians know that most Americans don't dissect misleading information thrown at them like in this video, it works most of the time. Well, maybe not for these students. Maybe they figured it out. Maybe they started thinking. Try it yourself. You'd be surprised you might learn something. Who's next?
Okay, ladies and gentlemen, my philosophy about participation in the classroom was created over a course of many years, but basically through two epiphanies. The first one was that if you call on students in class, it seems like there's always the same 4 or 5 students that raise their hand, and I wanted to avoid that. The second was an observation I made in the classroom during my tenure as department chair, where someone was lecturing and students were falling asleep, as you see the alligators are doing here. But she did occasionally call on students, except for a small group of students in the front of the room. And after the observation, I asked her why. And she said, you know, those students don't speak English very well. And I thought, what a disservice is being done, that all students need to be able to equally participate. The way to tell whether you truly understand something is if you can explain it to somebody else or not. It's very, very unimportant what you do in the classroom. What is most important is what the students do. In fact, you heard about the guy who went to India and embedded a couple of computers into walls and gave no instruction, and the students ended up teaching themselves very nicely a variety of disciplines. Well, by including participation in your classroom, the biggest complaint I hear is the last one. I have so much material to cover. How can I possibly do that if I allow students to participate? Well, I can tell you that you need to give credit to your students, that you are the professor, you provide the outline, you provide the resources, you create a safe, non-threatening environment, you make sure the students participate and they can actually teach themselves as well as you can teach them. I mean, the thing you have to do is highlight, motivate, and summarize. You need to tell students that exercising and thinking rationally can change their brain cognition from stereotypes and misconceptions to be able to become a self-directed learner. And I found that when I do that, I have a much better relationship with the students in my class. I create a safe atmosphere where students can feel free to ask a question, and I don't even say that's wrong, or I might even say that's the right answer, but to a different question. Have you heard the quote that math is not a safe, well-traveled highway? That it's an adventure, and you have to be open to trying new techniques, and it might be messy. I'm trying something new right now. I'm in the position of taking a 4-lecture-hour course, and instead of lecturing for 4 hours, I'm ending up lecturing between 45 minutes to an hour, and instead the students are working in small groups and teaching each other the material. Okay, back to calling on students equally. You can go down the rows. You can use random number generators. There's a lot of ways to call on students at random. Now, most of my teaching is online at my college. And so, to tell you the truth, I think that I have interaction and participation in the classroom down very well. But replicating this online is the big problem. I'm just not sure how to do this, and it kills me because I'm a firm believer that anything we do in the classroom can be replicated online. I know there are tools out there. You can do voice threads, blogs, and wikis. You can have students create screencasts. There are a variety of topics you could ask students to present in an online course. You know, have them talk about a mistake they made and what they learned from it. Use one of the Angelo Cross classroom assessment techniques. Ask cool questions like, which is bigger, half of a small pizza or 1/4 of a large, and explain your answer. There's no right answer to that, is there? You've got to do some internet research and find out the size of pizzas and use calculations and formulas for area to explain your answer. This was a great one. You may say, well, Fred, these questions are all fine and good, but they have nothing to do with what's going to be on the test. But I am telling you that you can gain intelligence and problem-solving skills by asking questions that don't necessarily have anything to do with your tests. It's very risky. For more of these types of questions, I was the keynote speaker at last fall's CMC Cube South. You're welcome to go there for more of these types of questions to create problem-solving skills and make your students self-directed learners. Good luck. Thank you very much.
donate some food to us. Person back there, help yourself, please.
Thank you. Oh, great. Thank you.
Hello. Any Portlandia fans out there?
Oh, yeah.
Cacao. There you go. Well, okay, how do you like this one? Well, another day passed and I didn't use algebra once. All over Facebook. Well, another day has passed and I didn't do a deadlift once. Because that's not the point, right? It's about form, it's about getting your stuff in your brain to light up, and that's like algebra. You know, algebra is, it's what someone said earlier, it's like exercise for your mind. I was going to talk about that. All right, so what I've discovered is, because I did have a little health scare. I had a high blood pressure, and back in January, I was at the highest weight ever. And so I finally got a fitness trainer, and I discovered that what she was saying to me is what I say to my students, and this is one of the scariest pictures of me right there that's only going to be up for 15 seconds. That was in January, and I said, okay, something's got to happen. I had bloodshot eyes and stuff. So have a vision, have a goal, just like we want our students. I tell my students to have a goal. So I realized that I really like powerlifting and liked weightlifting. So I hope that's me in May, right there in the middle. And I hope that's me when I'm 75. She's awesome. Measure often, mark your milestones. I tell my students that. We measure me every month, and it's nice to see most months things are going down. And I have, on Pinterest, they had marbles. It's pounds to go on one side and pounds lost on the other, but I use beer caps. That's much more fun than marbles. And there are more beer caps on the right now. Woohoo! 30, actually, beer caps. Thank you. Lots to go. Okay. But like students, we want to see your milestones. Oh my gosh, best pretzels ever. At a ballpark, yeasty, slide butter on them, salt, awesome. They have cinnamon sugar in the back if you work there. Yeah, but no, what I do, quinoa sushi. Yeah, because you don't want to eat too much rice, so I replaced quinoa for the sushi, for the rice. So get your money's worth. If you cheat, you're only cheating yourself. How many times have we told our students that? If you cheat, you're only cheating yourself. Change it up, step it up, compete with the best. Shock your body. My trainer was telling me that too. We got to change it up. We're going to have to do burpees today, things like that. And this is actually a 12-year-old team. Look at that guy in the middle. Talk about stepping it up. They're all 12. So. Have a support system. Look for the helpers, like Mr. Rogers says. These are my two biggest fans, my husband and my son. And there are friends that are going to make fun of what I eat, my quinoa and my chia seeds. And send reminders and motivations. I noticed my trainer would send out things as I had a Whopper going into my mouth. It was like she knew. And she's like, your body's a temple, So, and I discovered Remind 101. In Remind 101, I send text alerts to my students. Remember to pack my paleo snacks today. Best day ever. Be prepared, just like the students that are forgetting their paper and their pencil, and they're not eating right, and I wasn't eating right. Learn properly from the experts. I think some of our students have learned incorrectly. I feel I sometimes have to deprogram them. However, they learn to do LCD all the time, and not when they're supposed to. So, do that. When it gets rough, just remember it's temporary, just like when you're on E. I tell my students, it's only 4 months. This test is just in a few weeks. So when it gets rough, it's just temporary. You can get through it, and that's what I tell myself. Take your glasses off. This sounds kind of weird, but I take my glasses off when I work out because I don't want to see anybody looking at me, okay? So, because that's not really pretty there. See what she's doing there? That's not pretty, but the results are awesome. So, I pretend they're looking at me, and this reminds me of, like with students, what I thought of was a student a girl who was very smart, except when a certain cute boy would sit by her, and she'd be like, I don't know how to sound, So, anyway, thank you, remember, and please excuse us as we make improvements. And I just narrowed down what I could find that did it. And I love a smoothie you can chew. Yeah. Thank you.
All right, hi, it's me again, and this is my last one, I promise. I loved what Becky shared because she's bringing who she is into her classroom, and I hear it in all the presentations. For me, I realized being a math instructor is not enough to help our students. I could be the best, I could plan the best math material, class worksheets, I do all this work, and I taught intermediate algebra for 2 semesters and had a 50 to 65% pass rate, and I was really bummed, and I said something needs to change. So I decided to morph my role to become a math coach. What a math coach does is that she looks at students holistically. We realize they come from a past, a present, a future, that they have strengths and weaknesses that they bring into the class. And my job is to encourage and motivate them, take their strengths and utilize it, figure out what their weaknesses are, and figure out a strategy to overcome those weaknesses. 2 main tools that I use. One is I did not have to reinvent the wheel. I use a Strategies for Success by Lynn and Marianne called Study Skills. These worksheets really basically spelled out everything that I wanted to bring into my class. The second thing is I brought myself. I brought my own personality, I brought my own strengths, my own weaknesses, I brought what my vision is, why I want to teach math, my own stories and my own pain, and I brought myself to the class. So what I did is I take 5 minutes of each class to do some coaching time. And it's not me preaching at them saying, you could do it. It's them writing things out, them talking to the classmate, and we share as a class. Just 5 minutes, and it made a world of a difference. The first day of class, I had them identify, why do you want to pass this class? Not just because you want to graduate, but why do you want to graduate? Go beyond that. You have to have a vision to push you forward when things get hard, and they got to share with each other. After each exam, I had them do a test analysis. That's one of the worksheets in the book, which really is a self-analysis. They went through each problem that they missed, wrote down why they missed that problem, what steps do they need to do to change that. Without doing analysis, we're going to repeat cycles. I had them take notice of what they think about me, what they think about the class, what they think about themselves, about math, and turn those negative thoughts into neutral thoughts. And we were able to voice them and figure out how to do that. I took the whole stigma of getting help and I just chopped it out. I said, getting help is not a weak thing. I brought in people from the disability center, people from counseling center to do a little 10-minute blurb once a week or so to share about what help was provided. Look beyond the mundane. You're not just solving fractions, no. You are exercising your mind and developing that critical thinking skill that's going to help you in relationships, in life, and all these things. I challenge them to look beyond the mundane of what we're doing. And I had them enjoy the journey. At the end of college, they might not remember that formula, but they will remember the people that were around them. The more that they enjoy their college life, the more chances that they will in succeeding as well. And there were a ton of other math skill or study skills that I had them do as well, which is up there. One thing I threw in is I did a mid-semester teacher's evaluation on Rate My Professor or a Google Doc, because at the end of the semester when I read the evaluations, it's no good for me anymore, because that class needed X, Y, and Z. I needed to know in the middle of the semester, so I solicited feedback from them in the middle of the semester. And community college really should be community college. It's not loner college. So that's why, like I did before, the whole Facebook thing, because I wanted to create a community, because that's something that is my value. So was it worth it? Like I mentioned before, 50 to 65% pass rate when I was just a math instructor. When I became a math instructor and a math coach, keeping the same material, my pass rate came to 91%. And I said, something happened here. Something happened. There might have been other factors as well, but I definitely think changing my role was a factor. So, and another perk is I just enjoy teaching. I figured, what am I learning in my marriage right now that I could bring into my class? What do I learn? What am I learning spiritually? What am I learning in all these other areas of my life that I could bring into my class and help them succeed in math and life? And the question I'll leave for you is, who are you that you can bring yourself into the class. We've heard a ton of presentations of people bringing themselves into the class. So I would say each one of you is different. Bring your strengths, your weaknesses, your values, all those things, and bring it into the class, and it will definitely help your students. Thank you.
Hi, I'm Larry Perez, and I'm going to talk about a technique I'm using in my pre-algebra class called flipping the grading, improving student learning through a self-assessment. So I'm going to start with a story. I'm driving around on Wednesday night, and it's warm, and I'm thirsty, and I see this sign, and I go to the clerk, and I lay down a $1 bill, and I say, give me 150 sodas, and I want my change. And of course, he gives me a dirty look, which I probably deserved, but we obviously have a different way of interpreting things. And of course, I wasn't about to have a conversation about how much does he charge me for a gallon of gas. I'm a mathematician. I take this sign literally. It says $3 and 75 hundredths of a dollar and 9/10 of a dollar. So how much is this guy charging me? So obviously there's a break in the communication. So it really boils down to communication. For instance, if I want to say hi to someone, I'm going to encode this message by waving. You're going to see it by sight. You're going to perceive it, whether or not you like me or not. And of course, you're going to receive the information and give me feedback. If you like me, you'll say hi back. If not, you won't say hi. But let's take this model and adapt it to the developmental math classroom. And think about the instructor who encodes a skill and delivers it through some channel, say a worksheet or a screen. The student's going to decode it in a certain way depending on whether or not we're talking with the same frame of reference. And one thing we should realize is that once we design these tools for students to learn from, we lose control of it once it gets into what we call this student learning environment. And there's a lot of places where the message that we send to them can get corrupted. For instance, if they don't like learning from a computer, they're not going to receive the message in the way we wanted them to. And the feedback we get is actually grading. So what is grading? Well, we generally grade our students' work to evaluate individual students' learning and performance. But what happens when students grade their own work? We allow them the opportunity to provide them with a means of self-assessment so they can determine what their weaknesses are and develop strategies to prevent that from occurring. And that is really thinking about the way they're thinking. This is metacognition. So having students grade their own work makes them more aware of what their weaknesses are, and hopefully they can develop strategies to prevent these errors from occurring on errors. So flipping the grading, one example is to give them an extensive take-home quiz over the weekend. Then we give them the solutions and a self-assessment survey, and we as the math instructors grade the self-assessment. And what do these things look like? Well, here's an example where we ask the student to define the problem they had most mistakes in. And here's what the student says. I should really be patient and look carefully at those signs if it's negative or positive. So they're automatically developing a study strategy, or a test-taking strategy rather. In another example, we asked them to define the question where they had the most mistakes on, and again, what are they going to do to prevent it? Well, this particular student actually just acknowledges that they're so dependent on their notes that that is a problem that they're having. Another time, in another question, we asked them to look at the text and define the section where they're having the problems at. So we're actually having them evaluate the text and their ability to do the problems in the text and to define the skill that's causing problems. And so, in another example, we often let our students make exam corrections. Well, in this case, yes, we grade it, we give it to them, we have them assess, me grading it, but them grading themselves. And what does this look like? Well, in some cases, students can clearly look at the errors, and we ask them to define it. And this student says, I messed up on order of operations, I didn't calculate a few numbers correctly, I didn't solve some of the exponents properly. That's exactly what we want our students to think, at least what I do. In this case, this is very interesting. The student distributes, but makes a mistake when it's a positive 2 and a negative 2. So it's very clear to the student what their mistakes is, and the student reflects on this. So we have to think, is there a way for us to possibly encode this data? And I came across this assessment called traffic light self-assessment, where students actually color code their exam based on how much knowledge they know about that particular topic. Green means they know it well, yellow means they don't know it well, and red means they don't know it at all. But think about, students can actually see patterns in what they don't know, and then we can get group to group, peer-to-peer tutoring, and this takes us all the way back to the communications model. In peer-to-peer tutoring, there's less chance for the message to be corrected because they have a common frame of reference. And the student who's teaching it obviously learns twice. And so, With that said, I want to say that there are signs that benefit us and signs that don't. And in this case, I bought 20 gallons of gas and I saved 2 cents. So that's my talk on flipping the grading, and that's my 2 cents.
So hi, I'm Erica Hasford, and this is my lovely assistant, my sister Jennifer, and this is my magic coffee. So what it is I'm talking about is, right now it's a LUC, it's a little open online course that we hope will become, a MOOC, and right now it's free, not for credit, and it's not graded. And so what it is students can sign up for this, and they can take math preparation content to prepare for their AccuPlacer, and also just-in-time instruction. And who is it that's doing it? I'm with CCC Online, which we do online classes for 13 community colleges in Colorado. And Terry, who is the academic dean, and myself, who are former math teachers and still math teachers in our hearts, we created the MOOC using NROC content. And that's my granddaughter there, which I'm absolutely just crazy in love with. So I had to gratuitously put her in the picture. But we're providing it to all the students in our system, and it's actually open to anybody that wants to try it out. So why are we doing this? It's a soft landing for the students that don't place into our DevEd courses. We have gone from a 4-semester sequence of DevEd courses in Colorado to just 2 courses. And students are supposed to place into one or the other. And so this soft landing allows them to have that opportunity to do this. And when? Good. So, we did a pilot in the summer. It was a 6-week pilot. We had over 100 students, even though we wanted to do 15 to 20. And the students were really happy with what we did. We have another session running right now, and so if you're interested, or your students are, please talk to me. I can give you the link, and we can get you guys started. And then we're going to run sessions every semester, hopefully at least a week or 2 before classes start, so students can take the prep work they need before the semester starts. Where we offer it is, we're an online consortium for the 13 community colleges in the system of Colorado. We're using an open course shell with D2L, and it's through us, CCC Online. So if you look us up, you'll see an advertisement for our MOOC, and anybody can register from there. And within the course itself, we're using NROC content, and I don't know how many of you know about NROC, but it's an essentially free, open resource content that gives us the content. And so the way that this is working, again, we're using their open course shell from D2L, which if you use D2L, the open course shell is actually a lot nicer to work with. It's a lot more navigable. And then we're using the NROC content, which provides something similar to what the publishers do, but for a whole lot less money. And then we also tell them, if you want to place into this course, here's what you need to study. And my sister is here to tell me when I space out, which I just did. But the way that the NROC content works is that the students, they take this diagnostic at the beginning of each unit. It tells them what they need to study, what they already know, gives them a learning path, and then they, I'm way behind, aren't I? But anyway, they do a diagnostic, they study, they master, they complete their learning path, and then we do some fun things in there. We're trying to do some videos by us so they get to know us as faculty members. They know we're not robots. And we're also trying to put in things about fun links like Dr. Michio Kaku, and also things about hippos, which really doesn't have much to do with us except for Hippocampus is part of NROC. We're very happy with NROC. And so far what's happened is that in summer we had over 100 students. Right now we have 120 plus students, and it's increasing every day. And the students are doing a lot of work within the course. A unit is a chapter, and some students are actually completing almost all the units, which takes them from pre-algebra all the way through intermediate algebra, which to me is absolutely staggering. Things we want to do in the future is get more data collection and get some peer tutors in. And so if you're interested, talk to me. I can give you the link, or go to CCC Online, and it's part of one of the banners that says sign up for our MOOC and join it, have your students join us, and we'd love to have you. Thank you very much.
Hello everyone, my name is Latrice Williams, Associate Professor of Math, and tonight I am going to present to you your STAT class. So what is it exactly? Well, it's a web-based course that I created, and I wanted to create a platform that would bring the wonderful world of statistics to individuals all over the world. I was inspired to create this site because of my students. I'm often asked for additional resources. And if you've ever tried to find additional resources for statistics by going to Google or YouTube, you would find anything from statistics on the bird population to a graduate level statistics course, all the way down to a 3rd grade statistics project using Oreos. And so for my students who try to find additional resources online, they often struggle. So I created this site that will put those additional resources in one place. So I created this one-stop shop for learning statistics. It's absolutely free, so anyone who has internet access can use this website. There's no login, no registration, no sign-up. The information on the website is equivalent to a first semester statistics course. And it has a full course curriculum. There's a textbook that I've authored, along with homework, videos, tests, and final exams. The textbook itself has 11 chapters. And the topics range from descriptive statistics, probability distributions, confidence intervals, hypothesis testing, correlation, regression, as well as ANOVA. The textbook also has the formulas and tables included. It's also been peer reviewed and class tested, and it's also open source. And so for instructors out there who are interested in using an open source textbook, you're free to go to yourstatclass.com and allow your students to use it. There are also videos on the website. I created over 30 step-by-step videos to show students how to work out the major statistics problems. For students who are visual learners, especially in math, they can view those videos for additional help. The videos are mainly housed on YouTube, and so if you're interested in linking to the videos, you can. They're absolutely public. Anyone can watch them. They're ordered by playlists that correspond to the chapters in the textbook, and so that's how they're ordered on YouTube. There's also homework. I created homework for the 11 chapters in the textbook. And the homework questions, of course, practice makes perfect, and so if students are able to practice more, they're able to understand the material. There are also tests and final exams on the website. I created tests for each of the 11 chapters, and I also created final exams, and there are 4 versions of the final exams, and there are over 100 questions each on each final exam. There's also a Twitter component, which I like because I'm able to communicate with my students and interact with them in real time. If they send me an email or post to a discussion forum, I don't always get that information quickly, but if they're able to tweet me a question, it comes to my cell phone, and I get a little buzz, and they're able to tweet me a question, and I can respond back to them. So here's an example with a student tweeting me a question, and I responded back to her. So I really love using Twitter to communicate with my students. So you may be asking yourself, how can you use the site, or how can your students use the site? Well, again, it has many uses. One, it's an additional resource for students struggling to find extra materials. For students who are interested in taking the course, and so if they need to take it with one of the faculty members, it allows them to preview the information in advance, and so they're better prepared when they actually do take the course. For faculty members who are interested in the flipped classroom or the blended learning model, this site has a lot of the resources needed to support those models. Again, it has the videos, textbook, homework, tests, final exams, and so you're able to send the students home to do the work and then use class time for activities, projects, experiments, and create this student-centered learning environment in class for deeper understanding. And so if anyone is interested in using the website or telling your students about this additional resource, the website link is www.yourstatclass.com. You can also follow the Twitter account, or you can subscribe to our YouTube channel. And if you have any questions, you can email me, or you can leave a message on the contact form on the webpage, and I will get back with you. Thank you.
Hi, I'm Shelly. I didn't put my name on the first slide because it's at the end, so I figured don't be redundant. Best for last? Maybe, I don't know. You decide. Active learning is what I enjoy doing, and so I'm going to tell you some things about verifying trig identities. So please don't let them die. They're a wonderful, wonderful tool. A little bit over there. I can't see my slides now. So jigsaws, what we're doing is we're going to take the pieces and pull them apart, and we're going to use all the students as a piece to the puzzle. We are going to get them involved in the learning process. We are going to get them discussing ideas about problem solving, misconceptions. What do they really know? What do they really don't know? You can use a jigsaw in pretty much any part of your math classes. And verifications, it's a really easy place to start. I don't start with the jigsaw first, though. I start with me and these little pieces of paper. The whole identity is here. Chop them up, put them on the document camera. They tell me the order. So when we start with the guided practice, we have to figure out what goes first. A lot of students don't even know where to start. So they look at it and go, I have no idea when it comes to verifying. So when we put all the scripts out, then they understand that I have an end and a beginning that have to match, and then I have to figure out the order of the pieces in the middle. So when we verify, we know that it's going to be tough first. We've got to get them comfortable, and this is a way to ease them in and get their comfort level up. So when we first start, and I model for them, they get a comfort level with verification that they maybe haven't had before. We know choosing a side to work is the most important piece. How often do they choose the wrong side? A lot. But that's okay, because they can recognize once they start doing them and we get the patterns established, the practice makes perfect. So when we get them to visualize, maybe with graphing or other things, in this particular one we're using a co-function identity, and they need to understand the relationships in the phase shift. Not always co-function, could be something else. So when we work with that, we are eventually going to get to know where we have the end in mind. So ratio identities, we're going to Pythagorean identities. They're going to have something that's going to help them get from beginning to end and step by step. So I model for them. I'm at the document camera doing what they tell me to do, putting in order. So once we get to that identity step and we do the verification, we don't do the QED statements, right? They don't understand quota, errata, demonstrata. What they want is, I did what I was supposed to do. And that's all they really need. So now that we've got to this point and our conclusion is true, they see that the end and the beginning both match, and they're ready to take the lead a little bit. So I turn it over to students. We give them a different one. So when they have this new identity, they start off with putting the pieces together. So one student comes up, they do the first step. Then they pick another student. That student comes up and does the next step. So we're back to using the document camera. They're working together. We're not at jigsaw yet, but we're getting close. So we go step by step through another problem together, helping guide and lead them through. So again, they find the initial statement, know what they need to do. They know the therefore doesn't go at the beginning, it goes at the end, so I can't pick that one, even though there's two that are the same. Then we have another statement that we choose, picking a side to start with, so it's got to be one of the first two pieces. And then they'll go on and on and on using the steps until they get all the way through to where they can see some of the patterns working for them and moving forward. So when we look at our next step, they know that they have to see the one before it in some form. So in this particular one, they're going to find a common denominator because there's a subtraction. So they have an LCD they're going to use. And I didn't finish this one because, you know, eventually they're going to get from beginning to end verification complete. Now we're finally ready for jigsaw. So we have to model for them first so we can get them active. We need to scaffold a little bit, build some trust, get them working together, talking to each other, breaking down some of those barriers, because we know the first few days they don't know everyone, they're not comfortable. Remember, when you think jigsaw, you've got to have the whole piece and how the small parts work together. So independent pieces working together to make a beautiful picture in the end. So now each student will complete the same verification. So they all get one that's the same color. They're all paper strips cut up, they're working at their tables. So everybody works the orange one. They go through the verification, then they all stand up and walk around. They look at each other's work, they write down the steps, they make comparisons, they decide who's right, who's wrong, is the order correct, they fix the errors, and always talking through the rationale step by step. Why did I pick this one? Why did I pick the next one? And so on and so forth. So then we move forward, everybody gets a different one. So as they get more confident, they'll each have another one, and they're all different this time, so they'll work through those problems, and as they work through those problems, again, once we're done, we'll stand up, we'll walk around, we'll make changes, we'll go through the rationale and share. Which then takes us into board work models, phase 2 of the verifications. So rather than just sticking with jigsaws, we get into the next level. So jigsaws are going to scaffold for us, and they help us work with some of the things from the Common Core as well. So when we're looking at organizing student work, board work models are a really easy way to do that. We're going to understand some mathematical problem-solving processes. We know we don't want them to just mimic a bunch of steps that we do. We actually want them to get it and to work through those problems and work on critical thinking and problem-solving strategies. We want connections. We want to engage prior knowledge. We want them to reflect on what they know. We want them to check for understanding and chunk information in a way that maybe they haven't before. So in the process of doing these board work models, I got this from University of Kansas City, Missouri. They have a supplemental instruction program, which is a peer tutoring kind of situation. They actually developed this model if you've not seen it before. And it's a side-by-side kind of approach with problem solving. So 4 parts total. Prerequisites, math steps, narrative. You can find a similar problem or solution and work that out. Or you can talk about what you need to work on. What am I struggling with? What am I stuck on? So one of the things that we often don't do is give the narrative. What's the step-by-step? Formats. You can have them do it on the board, physically, whiteboards all around the room if you're lucky enough to have those. You can have students use individual whiteboards and writing down on that. You can have them do a note card, or you can have them do them on a sheet of paper. And I have 2 different formats. One is a 4-column approach, or one is a 2-column approach. So the 4th column, you put the prereqs and what I need to know, beginning and end. Or in the second format, you can stack them up side by side, so you have an up and down approach, and it's easier to fit all on a sheet of notebook paper. I did this on 11 by 14 initially. It's really hard for students to carry those around. Found a way to make it fit on 8.5 by 11. So top 2 columns, narrate, pairs up with the actual math steps. On the left, work the math. On the right, narrate your steps. So tell me what you had to do, why'd you have to do it, language of the course. You need to use appropriate terminology. So tell me the strategies you used. What kind of simplifying did you do? Be specific. This is an example of what a board work model might look like. First step, write down the problem. Second step, choose a side to work. Third step, they did a Pythagorean identity, rewrite it, then we have to factor, then we're going to do some kind of reducing all the way till the end. Bottom 2, what I need to know and what do I need to work on? Well, prerequisite material. What kind of information should you know about this? Well, you're going to have to know how to factor. There's a difference of squares in there. And you're going to need to know how to use your Pythagorean identities. You also probably need to know the definition of an identity, right? So that's all terminology, language of the course. And what I need to work on, never let them get away with leaving it blank. They always need to work on something. So if they leave it blank, hand it back, tell them, what do you need to work on? What do you need to know? So, critical thinking, very important. Keeping the end in mind. We know long term this is a huge connection to Calc 2, so if you are going to transition through the calculus sequence, you're going to want to build these skills, so you should try one and see if you can do a board work model for verification. Also have a plug for tomorrow. Austin, I did a paper plate activity, brought it back for this one. So if you've never seen the unit circle built on a paper plate, you can take your entire trig course, start it from a paper plate. So I'll see you Sunday morning at, I think it's at 8 if you're interested. Stickers, glue, fun stuff. Good way to end a conference. Again, my name is Shelley. Thanks for listening. Have a great night.
And that concludes our second annual Ignite event, and I encourage you, if you enjoyed the event, please say so on your conference evaluation form. That'll help support future Ignite events. Although next year in Nashville, the board has a special Friday night event, so there will be no Ignite event in Nashville, and we plan to resume it with more fervor and passion than ever in 2015 in New Orleans. Right, thank you very much.
thank you, Fred, for putting this all together for us.